and welcome Mindsetters. This is Learn Extra Live. Today we're doing physical science with Phil. Phil, how are you today?
I'm great, thanks, and you, Katleho.
Good, thank you. Please tell us what we'll be doing today.
Okay, well today we're going to be starting to take a look at vectors and scalars. Some of you might have done this before. For those of you that have, take some notes, and you guys have got exams at the end of the year. Everybody's doing this stuff.
Awesome. Awesome. So you guys know that you have to tune in. And if your friends haven't tuned in, tell them to join us too. You can go prepare your board for while I let you know where to get hold of us. So you already know our Facebook page is facebook.com/learnextra, and our Twitter handle is @learnextra. And since it's Tuesday and it's a really awesome warm Tuesday, we have some prizes. You know, there's the Casio calculator as well as the labeler. This is to the best and most interactive mindsetter of the day. So make sure that you are that person. And thank you to Liberty. Liberty is always awesome. And as you guys know, my voice is a little husky today, so you're gonna have to bear with me. And if you can't hear me, tell me on the page, okay? Because I will be on the page the whole show, and I expect you guys to be there with me. Over to you, Phil.
Thank you so much. Okay, well, Mindsetters, today we're going to be taking a look at vectors and scalars. Now, even the matrix should be tuning into this show. It's a section which haunts you all the way up into university unless you get it right, and it's not that difficult. So later on in the show, we're going to be walking around, and we're going to be walking in a different way than we've done before. Okay, so these words, vectors and scalars, looks a little bit scary, really doesn't have to be. Now, what we've done is that calculator, that label is up for grabs. What we've decided to do is we've decided to make a challenge for you guys. I've done this for the matrix before, and I want you guys to get working on this. So get pens, paper, start writing this down, get a calculator, some protractors, some pens, pencils, all of that stuff out, and I want you to take down this challenge question. Now, first person to put up this challenge question, I'm going to be asking you to look at the page very, very carefully. Make sure that you guys are answering this. Now, just a reminder of how the challenge question works. I'm going to put the challenge question on the board. We're going to be posting it up to Facebook. And the first person to get the answer right with the correct explanation will get that calculator. So let's put up that challenge question, and here it is. So we've got this person which is walking. Okay, well, this is slightly different to what we've done before. Okay, so we've got a person which is walking 40 meters south and then 30 meters east. Their displacement is. Now, this seems very, very simple. Okay? Now, for those of you that haven't done displacement before, this might seem a little bit weird. And for those of you that are just getting into this, this might seem very, very simple. Okay, well, I walk 40 meters, then I walk 30 meters. How difficult can it be? Now, the answer is not as obvious as you think because of this word displacement, and that's something quite weird. And here we go. We're going to be explaining today exactly what displacement is and how it's different to distance. Now, we've seen something like this before. We've seen 40 meters, and 40 meters gives us an indication of where we're going. Now, I want you to make sure that you actually notice what's going on with the units. Now, we've left off one of our units. I want you to try and spot what's going on. That's the first part of your challenge. So if I've got 40 meters south, I know where I'm going, okay? Now, there's a lot of information there. There's a number, there's a unit, and there's a direction. Now, the next time I say it, there's something actually missing here. I've got a number. There's something missing inside there, and I want you to guess what it is. And then east. Something very, very strange going on there. Let's see what's going on. Let's see what displacement. Let's see what distance is, and let's see the difference between vectors and scalars. Now, if you pay attention during this lesson, you can manage to figure out what's going on with all of these. Two of these answers look immediately correct. I've walked 40 meters, I've walked 30 meters, and that means that I've walked 70 meters. But just to give you guys a little bit of a hint, the answer is not as simple as it seems. So that should be giving you a little bit of a hint as to how to do this. I want you to get on that page, start discussing it, start sharing your answers as well. Okay, so let's get into the lesson. Let's start to take a look at these words, and let's try and see what's going on. Now, the only difficult part of this section, I think, is the words. So each stage, I'm going to try and explain each word as carefully as I can. Okay? Now, what we're going to do is we're going to take a look at this word quantity. Okay? So quantity is just a little bit of a revision. You've done this before in grade 8 and grade 9. A quantity is something which I can measure. It's how much of something I've got. Now, there's something quite cool about quantities, is they've actually got a tiny little identifier attached to them. So I've got an example over here on the board which says a person walks 10 meters. Not a lot of information. We know that there's a person involved. We know that there's 10. And then there's something magical attached to the end of a quantity. So what I'm going to do is what we're going to explain here is that there are units attached to a quantity. There's usually a number which is attached as well, and now that introduces another word. Okay, now a lot of people, especially the grade 10s, they struggle with these words. Okay, and well, units, a lot of you leave these off. Those are very, very useful things. What units do for me is they tell me what is being measured. That tells me what I've got a lot of. So this tells me what I'm measuring, and the 10 tells me how much of it I have. And that is called my magnitude. So what I'm going to do is I'm just going to really highlight this, because this is something that the grade 10s, 11s, and 12s really struggle with. This word magnitude is something that I really don't use in everyday life. It's something which is quite uncommon. The magnitude is how much of it I've got. So this is telling me I've got meters. So I've got distance. I've walked somewhere. 10 is telling me how many meters I've got, how many meters I've walked. Might seem a little bit simple, but the only reason that I'm starting simple is just to make sure that everyone is with us and that you guys can actually follow through and there's no problem so far. Okay, so just to revise, a quantity is something which I can measure. So that's something from grade 7 or grade 8, right? I know that I can measure a quantity. Two very important parts of any quantity, doesn't matter what type it is. I've got a magnitude, which is how much I've got, and then I've got units, and these tell me exactly what I've got. I cannot emphasize this enough. Please, every time you write down a final answer, you must give me the units. Now, your teachers are probably saying, okay, the units, and you're just saying, the number is fine. The calculator gave me a number, and that's everything. Well, if I tell you that you've got 10, the really strange thing is, okay, I've got 10 what? Now, over here, this identifies what I've got 10 of. It might not seem very, very important until you start dealing in currency. Now, if I walked up to you and I said that I've got 10, and well, you say, okay, well, I've got 10 what? Okay, I've got 10 rand. Great, I can buy something small. Okay? What happens if I've got 10 million? 10 million what? Well, if I've got Zim dollars, sadly. Those don't work anymore. But you'd be quite upset if I gave you 10 Zim dollars, because that wouldn't be worth anything. It's quite important to know what you've got. Okay, it's absolutely vital that I need to know what I've got. Okay, so there we go. So quantities, something I can measure. I've got to have a number which tells me my magnitude. Good word, just write it down, please. It's how much you've got. It's the size of the number. And then my units is what I've got. Well, let's start investigating some interesting quantities. Well, I bet you've never paid this much attention to quantities before, but I'm going to be bringing up some really, really complex words. I've highlighted them over here. Now, this word scalar. Now, it kind of sounds a little bit similar, but is not quite the same as a scale. Now, anything which can be scaled can be measured. Now, this is something quite interesting. This is my first type of quantity. A scalar is a measurement that only tells us the magnitude of something, so how much I've got of it. All scalars do have units, because a scalar is a type of quantity. Now, let me just make that clear. A scalar is a quantity, but now it's limited. I just want to show you just how limited it is sometimes. So a quantity, that means that it's got a unit, it's got a magnitude, it tells me how much of something I've got. The problem is that scalars can be great for some things, but for some things they're not sufficient. Now I'm going to give you a few examples as to where a scalar is actually going to leave you in trouble, and where we need to take over with a vector. Sometimes a vector is better, sometimes a scalar is better, sometimes you have no option. So now a scalar only tells us the measurement with the magnitude, and that's very important. A scalar only has magnitude. It only tells me how much of something I've got. Now, what I'm going to do is, each time I give up one of these examples, I'm going to be scribbling all over the board, so I want you to listen to me very carefully, write down what I say, and then hopefully get into some of the stuff. So magnitude, again, is how much of something I've got. Now, what I'm going to do is I'm going to write down a couple of scalars, and I want you to start matching a pattern to all of these scalars. I want you guys to discover. Now, the problem with teaching is it's great when I talk and you seem to be understanding everything, you're writing stuff down, what I'm saying. The problem is that you need to actually start discovering stuff for yourself. Otherwise, you're not going to remember anything. So now, if I've got a magnitude of something, what we're going to do, and I like the word magnitude here. You're going to hear me say it 1,000,000 times today. Well, let's give you a few magnitudes and units, and you tell me what these things have got in common. Well, let's start dealing with some stuff, right? I gave you an example a little bit earlier. 10 that means something. 10 kg, that means something. 10 s, that means something. Now, from looking at these, it's quite difficult to tell what I'm looking for. What I need to do is I need to realize is that I've got a magnitude of 10 in each case. So that magnitude over there, I've given you 3 magnitudes. I've also given you 3 different units. The reason that the units are so important, because that tells you what you've got. So I've got 10 m for meters, 10 kg for kilograms, 10 s for 10 seconds. These guys have all got something in common, apart from the fact that they're 10. I want you to ignore the 10. There's something else quite special about these. I've only got the magnitude. Now, what else can these actually give you? Well, it's going to become clear as we start moving through this. So that's what a scalar is. Let's see that we've got an example. So I've got an object which has got 80 kilograms of mass. Let's just point out the bits and pieces which we can find out about the scalar. Again, a scalar is a quantity. So let's figure out what we've got. So the object's mass cannot have a direction. Now this is something quite limiting, and you might say, okay, well, of course it can't have a direction. Now this is where we start to bring in something called vectors. Now, if that's not immediately clear, just stick around, start writing down what we're saying. Okay, now I've told you about this object with 80 kilograms of mass. The nice thing about it is it will have the same mass everywhere. You cannot put a mass in a certain direction. That's movement. Now, a mass does not have a direction. This is why I say some things are scalars, some things are vectors. Some things you can't choose. I cannot choose for mass to become a vector. Now, if you don't know what a vector is, it's coming right up. So this object cannot have a direction. It's absolutely important that this idea of directions and quantities starts to come into play. And it's the same anywhere. Scalars are the same all over the place. Doesn't matter on anywhere on Earth, scalars are going to be exactly the same. Okay, so let's start moving a little bit further than that. Now, that this object cannot have the mass is quite important. Now, how can we introduce this idea of direction? Let's actually move that out of the way so we can actually start to introduce something else which does have a direction. Now, most of you that have done grade 9 and you've started dealing with mass, force, energy, power, knows that there's a difference between mass and weight. Now, most of you are screaming at me saying, okay, well, 80 kilograms, I can change that into a force. I can find out how much force there is on 80 kilograms of mass, but it depends then on where I am. Now, 80 kilograms is something which would stay the same on Earth, on Jupiter, in space. It's exactly the same. What I'm going to do now is I'm going to try and figure out what about weight. Weight does depend on where you are. So now what I'm going to do is I'm going to change that into a quantity. And that would be 800 newtons of weight. Now you might say, okay, well, where's the direction for weight? Well, you try to throw something up. What immediately starts to happen? What direction does weight always act in? All of a sudden now we've got a quantity which requires a direction. And that's where we come in for the need of vectors. Okay, so now other examples of scalars, things which do not have direction. Okay, well, distance, speed, and time. Now you might say, okay, well, these sound very familiar because I've been calculating these in maths probably. So distance, speed, and time. I've dealt with these before. Okay, well, distance just requires us to measure things in meters for it to become a distance. So there we go. There's my distance in meters. My speed in meters per second. Or we could even measure, if you're inside a car or a vehicle, you can say kilometers per hour. Now you're going to see me change the units very, very slightly. The reason that I've written it with a slash is because some people haven't done exponents in maths yet. And I want to introduce you to that very, very slowly. Time is probably the easiest one, and time is measured in seconds. Now, in physics, in chemistry, it doesn't matter. Time is always going to be measured in seconds when you're doing calculations. Okay, well now, these don't have directions. These are just magnitude and unit. Well, let's start dealing with this thing called a vector. Okay, now, I've started to introduce it in some of the sentences that I've been talking about, but there it is on the screen. A vector is something that has got magnitude, of course, because it's a quantity, but here's the big thing. It's got a direction. It's absolutely vital that you know that all vectors have a direction. Now, that makes it a little bit tricky to answer vector questions. Vectors mean that I've got to add a direction at the end of each answer. I don't want you to just put the number, just put the units, and just leave it there, because usually when you're doing vector questions, don't forget about the direction. Please, 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 I can't emphasize it enough. That direction is absolutely important, because that's what makes this a vector. So it is also a quantity, so it's something which I can measure, but the big difference from a scalar is that a vector is something which has got direction. Now you might say, okay, well, what's the point of direction? Well, if I was to tell you how to get to somewhere, directions are very important. If I was to tell you to drive, okay, well, 100 meters. Okay, all right, so we're moving 100 meters. The question is in which direction? So 100 meters south, 100 meters north, all of a sudden we've started to make vectors. Vectors in many ways can be much more useful than scalars. Well, if I was to tell you that I was being pushed, for instance, if I was being pushed from the bottom, from the top, from the front, from the back, that would be quite important information to know. What would happen if you changed into the wrong gears inside a car, a taxi, or a bus? Now, what has to happen is inside, our gearbox decides our vector direction. That's quite important. Going forwards or going backwards is quite a big difference. Direction is everything when you start to deal with vector quantities. Absolutely important that you know the difference between a vector and a scalar. They're going to ask you these definitions. It's quite important to know. Okay, so now a vector has this direction. So, and a lot of you are saying, okay, well, so what? Well, as I said, when you start traveling, especially when you're traveling, there is our example. We've got a whole bunch of information. We've got 80 as our magnitude, kilometers as our units, and we've got a direction attached to there. So that's something quite vital to know. I need to know that I've got, okay, so there we go. Let's just move that around. Okay, so I've got my units over there, and it tells us what's being measured. What else is there? Well, I'm actually going to add a few notes onto this. Some of you might not be used to your cardinal points or your compass directions. So there's your first one. Okay, so that tells me where I'm going. So therein is my direction. That's hugely important because this identifies this as a vector. Okay, what's going on over there? There we've got our magnitude. You're going to hear me say that word so many times today. You're going to get sick of it, but you're going to know it. So my magnitude, my direction, and my units. This is a great way to answer a vector question. How far did I go? I went 80 kilometers. Where did I go? I went east in the process. So that means that I now have a vector. Now, vectors are a little bit tricky. The problem is there's many, many different ways of giving this direction. And as the show goes, what we're going to do is we're going to slowly decode it, slowly make things happen, and slowly help people through all these questions. So, what we're going to do is we're actually going to start off with probably the simplest way of giving directions. Now, this doesn't always apply. Now, some of you at home are probably saying, okay, well, what are cardinal points? Cardinal points is a bit of a weird thing. So what I'm going to show you now is how we work out those cardinal points. Most of you have seen the compass points before, and those are cardinal points. So what I'm going to do is I'm going to start off with these two crosses over each other, and we're going to put in our cardinal points. So if I've got N for north, E for east, and S for south down at the bottom, and then finally west. The problem with this is sometimes we're not actually given compass directions, and that's going to make things tricky. Now, I just want to leave on a little bit of a hint before we go to an ad break. Our challenge question does use cardinal points, but it uses something else. You're going to need to take a look a little bit after the ad break, but I'm going to leave it there. What do you think?
Yes, let's just go for a quick break. I just want to remind you guys about what Phil said. You need to substantiate. You need to tell us why exactly you choose the answer that you choose. Because I can just see A, B, C, D, E, F, G. Let us know why you're choosing that, because that's how we know that you actually understand.
And you're helping others.
Yes, and you're helping others understand it further. See you right after the break.